In this short video, I'm going to discuss the live dead cell analysis protocols, which are part of the cell biology protocol collection. The protocols are designed to measure the population of live versus dead cells. There are 4 live dead cell protocols based upon the fluorescent marker inputs available. First, select the count size ribbon and press the protocols button. Selecting the cell biology collection, scroll down to the live dead cell protocols. There are 4 live dead cell protocols based upon the fluorescent markers available in the experiment. So we have live dead, which means we have a live and a dead marker in the experiment. We can use this protocol. A total marker for identifying the total number of cells, and a dead marker. Total and live, and total live and dead. For this demonstration, we'll be using the total live and dead live dead cell protocol. Simply press the load button. And this will bring up the total live and dead protocol. Each protocol includes a set of demonstration images, which we'll use for this demonstration. You may also use your own images and modify the protocol accordingly to your needs. First, we'll select the load demo with the open demo image checked, which is located next to the reset button. And this will bring up the demonstration image. I'll adjust the normalization a little bit by bringing in the black point so you can see it clearly. And so this image set or composite image includes a GFP, a host, and a PI marker. We're already set up for the host to be the total cell marker. Live is the GFP, and dead is the PI. For your own markers, if you're using your own data set, just select the appropriate channel. With the interactive setting checked, press the next step button to continue the protocol. The cells have already been segmented, and we can adjust that using smart segmentation, and we can draw new reference objects. This is very well segmented already, so we'll just continue with that. And you can also use normal intensity thresholding for your protocol if you would like. Simply press the OK button. Next, we have a few options where we can scrap out minimum areas. So if you have some disrupted cells or broke over just some non-specific debris, you can scrap that out. Clean borders if you only want to count whole intact cells. We can fill holes within the nuclei. And right now, the watershed split is being applied. You also have the choice of applying no split or boundary shade. Every protocol includes an interactive step, which means that when you run your batch mode, the protocol will stop at this step and you can make adjustments accordingly. In this case, we're going to set up the protocol to confirm the settings for this data set, which can then be applied to other data sets of similar type in a batch process mode. Next, press the next step button. Now we'll segment the GFP channel. In this case, and I'll just turn off the show for a second, and you can see the GFP channel is already segmented. And what you'll also notice is where we found the nuclei using the total marker, you'll see outlines around each cell or each nucleus. In this case, it's already fairly obvious. There's a few dead cells here. Again, we can adjust the segmentation. It's already done well, but we can draw additional reference objects over the live using our smart segmentation tool, machine learning, or additional background reference objects or areas if we need it. In this case, it looks good. We'll press the OK button. And in the protocol, in the segmentation options, we only have a minimum area. This is to scrap out some, non-specific fluorescence because we're only looking at fluorescence that resides within the area of the nucleus defined by the total marker. Simply press the next step button. Now we'll segment the PI channel. Here we're using intensity-based threshold or smart segmentation, and simply select. One of the benefits of the protocol is any area defined by the nucleus that has the PI dye or the dead dye in it will automatically be scored as dead, even if it has the GFP marker in it, just because depending upon the state of the cell, you can start getting the PI marker coming in. And once the PI marker is in there, it will automatically score that cell as dead. So in this case, we're good. press the OK button. You can see the outlines where we've identified the PI die. Outside are just like a hot pixel or anything like that. Press the next step button, and all the data is calculated to report the population of live and dead cells. In this case, we produce a pie chart, heat map showing the pie chart if this was a multi-well plate data set, and then we report out the information on that particular image, reporting the number of cells, number of dead cells, number of live cells, and also reporting the percentage of dead cells. You can also include additional data that is subject of a separate video. Once we're complete, we press the finish button, and then if you're only analyzing a single image, you can export the data directly to Excel. If this was a multi-well data set or you have multiple images sitting in the folder to analyze, we could then run a batch process. Thank you.